Now we are going to solve the problem number 13, objective question in oscillation chapter. First I will read the problem. Look at here. This is the waveform of the damped oscillation. Okay. So in this problem what is mentioned now? When a damped harmonic oscillator completes 100 oscillations, its amplitude is reduced to 1/3 of its initial value. Look at here. Initially, the amplitude of the harmonic oscillator is A0. So A0 is nothing but initial amplitude of the oscillator, harmonic oscillator. Here I have drawn the oscillations shown in the form of waveform. As time goes on increasing, the amplitude decreases due to damping forces. The graph is drawn between time and amplitude. Initially, the amplitude is A0. As time goes on increasing, the amplitude is decreasing due to damping forces. Here you have to assume that this is the 100th oscillation. When the 100th oscillation is taking place, what is the amplitude? That is the amplitude of the 100th oscillation, that is 1/3 of the AO. It is reduced to 1/3 of its initial value. When it completes 200th oscillation, அதாவது 200வது ஆசிலேஷன் முடியும் போது என்ன ஆம்ப்ளிடியூட்னு பார்க்கணும். 100வது ஆசிலேஷன் வரும்போது 1/3 ஆஃப் த A0 இருக்குது. 200வது ஆசிலேஷன் வரும்போது அதனுடைய ஆம்ப்ளிடியூட் என்ன அப்படின்னு கேட்குறாங்க. ஆர் யூ கிளியர்? நவ் டு சால்வ் த ப்ராப்ளம், the formulas are not available, so we have to refer few books. Therefrom, clear, we are able to get the formula. I will write the formula which is not available in your textbook. Amplitude of the damped harmonic oscillator at any instant. At any instant you can calculate the amplitude by using this expression, that is A is equal to AO e power of minus BT. So this is the formula. At any instant you can calculate the amplitude of the damped harmonic oscillator by using this expression. Here AO is called as initial amplitude. AO is called as initial amplitude. Okay. So what about B? B is called as damping constant. B is called as damping constant. So these are all the meaning of AO and B. Here you should know what is T. Whenever any harmonic oscillator, when they are oscillated, you can easily find out the time period. The general formula is time period T is equal to, capital T is equal to total time taken divided by number of oscillations. Are you clear? T can be, capital T is nothing but time period. Total time taken to complete n number of oscillation. By using this, you are able to calculate the T. Here, we will write two cases. Case 1, I am going to write the case 1 for 100th oscillation. 100வது oscillationக்கு நான் ஈக்குவேஷன் எழுதுறேன். T is equal to, what is T? Time period. To calculate the time period, how to use this formula? Small t, total time taken to complete 100 oscillation divided by number of oscillation is 100. Therefrom you will get small t. Small t is equal to 100t. So this is case 1. Now this t can be substituted here for 100 oscillation. Here, how to calculate AO? Already it is mentioned. A is nothing but, okay, A0 by 3. This is the amplitude after the completion of 100 oscillation. Are you clear? Substitute A and T in this formula. How to write this? Look at here. Case 1 to be written. Instead of A, substitute AO by 3 is equal to AO e power of minus B minus b, instead of t substitute 100 capital T. So this is the equation written when it completes 100th oscillation. 100வது oscillation முடிக்கும் போது இந்த equation நம்ம எழுதலாம். This is case 1. Are you clear? Now here AO can be cancelled and finally you will be getting e power of minus b 100t will be equal to 1 by 3. So this equation can be written as 1. Okay, now I am going to write the equation for 200th oscillation. 200வது oscillation முடியும் போது என்ன ஆம்ப்ளிடியூடுன்னு கண்டுபிடிக்கணும். அப்போ எப்படி எழுதுறது? இதே மாதிரியே ஸ்டெப்பை ஃபாலோ பண்ணணும். Case 2 to be written for 200th oscillation. இதே ஃபார்முலாவை எடுத்து 200வது oscillation முடியும் போது யூஸ் பண்ணணும். எப்படி எழுதுறது? இப்போ எழுதும்போது time period is equal to total time taken to complete 200 oscillation போட்டுக்கலாம். அப்போது small t என்ன கிடைக்கும்? 200 into t you will get. Are you clear? Our aim is to calculate the amplitude of the damped harmonic oscillator after the completion of 200 oscillation. 200வது oscillation முடியும் போது என்ன amplitude அது எவ்வளவா குறைஞ்சிருக்கும்னு கண்டுபிடிக்கணும். இப்போ மறுபடியும் இதே ஈக்குவேஷன் எடுத்துக்கணும். இந்த ஈக்குவேஷன் எடுத்துக்கோங்க. A is equal to AO e power of minus நீட்டாக எழுதலாம். A is equal to A e power of minus bt. Here our aim is to calculate A. So A is equal to AO e power of minus b instead of the small t, clear, here small t 200 into t can be written. Here after writing this step we can write like this: A is equal to AO, this entire part how it can be written? E power of minus b 100 t whole square. In that format we can write. The next step, A is equal to AO. Already we know this expression, e power of minus b 100t is equal to 1 by 3. Therefore this entire thing can be replaced by 1 by 3. Power of square can be written. After that A will be equal to A naught 1 by 3 square is nothing but 1 by 9. Now the amplitude is reduced by how many times? 1 by 9 times. The initial amplitude is AO. Now the new amplitude is 1 by 9 times of AO. அதாவது கடைசியாக என்னது 9ல் ஒரு பாகமாக குறையிறது. இனிஷியல் ஆம்ப்ளிடியூடை கம்பேர் பண்ணும்போது 200வது ஆசிலேஷன் முடியும் போது அதனுடைய ஆம்ப்ளிடியூட் என்ன ஆகுது? 9ல் ஒரு பாகமாக குறைஞ்சிருக்கும் அப்படின்னு அர்த்தம். அதனுடைய மீனிங் அதுதான். 1 by 9 is the answer. Understood?